Tsunamis are one of the worst forms of natural disasters. As an example, the 2004 Indian Ocean tsunami, which had waves as high as 30 meters tall, once heading inland, killed approximately 230,000 people in 14 separate countries, making it one of the worst natural disasters ever in recorded history. Tsunamis, unlike normal waves, which are caused by the winds and tides by the gravitational pull of the moon, are caused by extremely large displacements of water. In the case of the Indian Ocean tsunami, it was caused by a large undersea megathrust earthquake that measured 9.2 in magnitude. This earthquake occurred along a 1,600-kilometer subduction zone where the Indian plate slid under the overriding Burma plate. As the overriding Burma plate bulged under strain, tectonic uplift occurred before eventually the plate slipped, causing a massive amount of energy to be released and thus causing a tsunami. This earthquake, which displaced an estimated 30 cubic kilometers of water, created waves with an energy equivalent of 5 megatons of TNT, which is more than twice the total explosive energy used during all of World War II. On average, 2 tsunamis occur per year, and approximately once every 15 years, a very large destructive tsunami strikes. You may be asking then, what made this particular earthquake and subsequent tsunami just so deadly, and how can this be prevented in the future? One reason is the close proximity of the earthquake to land and the extreme speeds at which a tsunami moves. The hypocenter of the earthquake was approximately 160 kilometers off the western coast of northern Sumatra within the Indian Ocean. Just 20 minutes after the earthquake occurred, the first waves were arriving at the northern tip of Sumatra, instantly killing nearly 100,000 people. Then, an hour and a half later, the waves hit Thailand, resulting in similar death and destruction. These waves continued to expand outward from the epicenter of the earthquake at a rate of about 500 miles per hour, or about the speed of a commercial jetliner, hitting all of the surrounding landmasses and bringing with it extreme amounts of destruction. The second and related reason as to why the tsunami was so destructive was that despite having some amount of time, although limited, between when the initial earthquake occurred and when the tsunami arrived, many of the countries hit by the tsunami were completely taken by surprise. At the time, there were no tsunami warning systems located in the Indian Ocean to provide any advanced warning, making it impossible for anyone to know what was about to occur. And all that being said, tsunami detection is not easy, as often the water disturbances occur in very deep water in which earthquakes may not be easily felt. In deep ocean water, for instance, a tsunami forms only a low, broad hump that is barely even noticeable even for a passing ship. However, near the coastline where the water becomes shallow, the tsunami slows down and forms the large destructive waves that we typically think of when we hear the word tsunami. These waves, which can be as tall as 30 meters once hitting land, can travel several kilometers inland, causing major death and destruction. The first signs of a possible tsunami are obviously the earthquake itself. However, tsunamis can strike thousands of kilometers away from where the earthquake occurs. Additionally, if the tsunami is caused by a volcano or a landslide, earthquake sensors alone will not be much use in the prediction of where the tsunami is to occur. Many analysts claim that the disaster would have been mitigated if an effective warning system would have been in place, such as the one that is located in the Pacific Ocean already. The National Tsunami Warning Center, which was founded in 1967 and is run by the U.S. National Oceanic and Atmospheric Administration, is the premier tsunami warning system in the entire world. This system primarily monitors the Pacific Ocean for tsunamis, as it is particularly susceptible due to the fact that it is home to a region known as the Ring of Fire. This ring is a direct result of the collision of tectonic plates and is home to roughly 90% of all earthquakes and 75% of all volcanoes in the entire world, thus giving it an increased risk for a tsunami to occur. The primary component of the tsunami warning system is what is known as DART, or the Deep Ocean Assessment and Reporting of Tsunamis. This system enables instant and accurate tsunami forecasts by monitoring the ocean floor. The DART system itself is made up of 3 parts: the pressure recorder anchored to the bottom of the sea floor, a moored large surface buoy and an acoustic transmission link that connects the seafloor and the surface modules. During normal operation, the system will steadily measure the water pressure at the sea floor. Since there is a direct relationship between water pressure and the height of the water column above it, the water column can be monitored over time for any anomalies simply by measuring the water pressure. If a large wave passes over where the DART system is located, it will measure a higher water pressure and thus a higher water level. If the calculated water level is not within recent data averages or the nominal water level, the system will initiate the tsunami alert process, indicating a possible tsunami threat. The system will first transmit an alert to the surface buoy using underwater acoustics, which will then pass this alert to a satellite and on to the Tsunami Warning Center headquarters for further analysis. After further analysis, and if a tsunami is indeed occurring, alerts via text messages, emails, and other emergency alert systems can then be sent out to the general population, alerting them to evacuate and head to higher ground. Today, the Tsunami Warning System consists of nearly 40 separate DART stations scattered around the Ring of Fire in the Pacific Ocean, as well as several stations in the Caribbean and off the Atlantic coast. As a result of the success of this system, many internationally coordinated systems have now spawned as a result, including many regional systems as well. For example, in response to the Indian Ocean earthquake and resulting tsunami in 2004, the Indian Ocean Tsunami Warning System was agreed upon at a United Nations conference in 2005 and has been operational since 2006. Today, this system has a total of 7 DART stations scattered throughout the Indian Ocean. In addition to this, there is also the Joint Australian Tsunami Warning Center, composed of 5 DART systems, and the South American system, composed of 8 DART systems. These systems, although managed independently, often work together and share data in an effort to provide as much advanced warning of potential tsunamis as possible. By relaying advanced warnings to people, the necessary steps can be taken to evacuate to higher ground and get out of harm's way as soon as possible. Hopefully, these systems and future planned expansions will be able to prevent another horrible natural disaster like the 2004 Indian Ocean tsunami from ever happening again. Let me know in the comments below what you think about the tsunami warning system and what ways you think it can be improved in the future. And as always, thank you so much for watching.